Congratulations, many congratulations. You have made it till the end of this series. So, this was the series on graph data structure interview preparation by me, Aditya Singh, and I hope you learned a lot from this. Now, with this, you are ready to sit in front of an interviewer and say with pride and confidence that I love the data structure graph. I feel very confident and I enjoy solving problems based on graph. So let's have a quick recap of what we have done so far, followed by what's left further to be explored by those who want an even stronger grip over the data structure, the graph data structure. So we started from the very scratch. We saw what basically a graph is or what graphs are, and we concluded that graph is nothing but a set of vertex and edges. Vertices are also referred as nodes sometimes. And then we basically divided graphs into two categories, namely directed graphs and the undirected graphs. And there is a separate division for graphs as well. And we can also divide graphs again into two categories, weighted and the other category as unweighted graphs. Throughout the series, we worked with unweighted graphs, and unweighted graphs can be divided into directed and undirected graphs. So can be weighted, but we worked throughout the series on unweighted graphs. In the unweighted graph, we discovered some interesting facts which are true. For example, in breadth first search, we observe that the breadth first search gives the shortest path from the source to any node that we are traversing. And this is true only for unweighted graph. Talking about the facts of breadth first search, we also discovered a fact on depth first search, and it was that depth first search produces tree for connected graphs. How to choose which traversal technique to use to solve a problem? Well, if you use breadth first search, what happens is the path information from source, that is the from starting point, to the current node that we are traversing. So current node that we are traversing is lost. So basically, you cannot track from what was the exact path which was used to reach this current node from the source. So if you are doing solving a question in which traversing the nodes is important and it doesn't matter from what path you are reaching the nodes from the source, right? What the exact path that you follow to reach the to reach the current node, you don't care. You can use breadth first search. Whereas in depth first search, it's not lost. The information is there. So if there is a question in which you want to track the exact path or paths that you are using to reach a node in the traversal from the starting point, that is source, you should use depth first search because the information is there and we can retrieve it. Talking about breadth first search and depth first search. Breadth first search uses queue data structure to traverse through the graph, whereas depth first search uses recursion, and recursion is nothing but stack. So depth first search uses stack data structure for traversal. In the series, after the understanding of the concepts, the theoretical part, we implemented codes and we practiced problems and not just discussed the approach, we actually implemented the solutions on the editor and verified our results as well. So we did practice a lot of problems here. And these problems were not just any problems, but if I were to say name them, I'd name them as interview must do. These were the problems that I shortlisted, which sort of give you a very strong understanding of how graphs are used and um, are popular in interviews and online tests for top IT companies like Microsoft, Amazon, Google as well. And now, if there was something that we didn't work on in graphs, it will be weighted graphs. We did actually see how to implement the data structure, but we didn't actually practice any algorithms or problems on weighted graphs at all. So that gives us a way to further explorations in graphs. And for that, the looking forward section, I would dedicate it to weighted graphs. So weighted graphs it is. The first thing that you should look up if you want to explore further is the fastest route. Google Map gives us the fastest route between two source between the your location and your destination. It might be using the Dijkstra's algorithm. It doesn't, but it can. And now I'll quickly name the problems or keywords that you might want to look up for if you are or if you are looking to explore further in the weighted graphs. So after the fastest route Dijax's algorithm, you might want to check out the currency exchange problem. And for that, we use Bellman-Ford algorithm. Another popular application of weighted graphs is seen in spanning trees. The problem that is popular in spanning trees is the minimum spanning tree. Minimum spanning tree problem can be solved using two algorithms. One is Kruskal's algorithm, the other one is Prim's algorithm. Both of these algorithms are based on greedy, so these are greedy algorithms. So the fastest route could have been found by the access algorithm, but there are advanced algorithms that give the shortest path, and these algorithms can be 1,000 times faster than Dijastra's algorithm, and in some cases they are observed to be 25,000 times better than or faster than Dijastra's algorithm. So to name a few advanced shortest path algorithms, one of them is bidirectional Dijkstra's, the other one is A-star algorithm. Then we also have contraction hierarchies. And if I were to mark the top priority topics among these in weighted graphs, I would say you must work on fastest route Dijkstra's algorithm. It is a simple algorithm and yet a very powerful algorithm. And I also recommend that you work on minimum spanning tree problem. And that is it for the weighted graphs section. So there it is. Congratulations once again. And again, I would like to say we didn't work on weighted graphs because I have experienced that weighted graphs is not asked in interview questions or online tests of the major IT companies, or as a matter of fact, any IT company. And that was the reason why I skipped the section. The entire idea of building this series was to prepare for graph data structure in a very short time so that you can clear your uh, interviews with good confidence in the data structure. So that was the reason why I skipped the weighted graphs section. But however, if you are looking at a phase of your life where you have a lot of time, you might want to further explore the weighted graphs section. As a matter of fact, you must. So this is all from my side. I am thankful for your attention, time, patience that you gave me throughout this series, and with the best wishes for your future. I'm signing off. This is Aditosh signing off. Thank you, everyone.